In December of 2024, humanity received a message from the bleeding edge of science. It wasn't an alien signal or a cosmic discovery, but an announcement from Google that has sent a shockwave through the world's scientific community. They unveiled a quantum computing chip named Willow, and it doesn't just work well, it works impossibly well. This isn't a story about a faster computer. This is a story about a machine that appears to be breaking the rules of our universe. Neil deGrasse Tyson, a man who has dedicated his life to making the cosmos understandable, was left grappling for words. He said, "What Google has achieved with Willow doesn't just advance quantum computing. It forces us to confront the possibility that our understanding of reality has been fundamentally incomplete." Think about that. Not just incomplete, like a puzzle with missing pieces, but fundamentally incomplete. As if we've been trying to solve a Rubik's Cube without realizing it has a hidden fourth dimension. This isn't a minor upgrade. It's a seismic shift, a rupture in our consensus reality. For you, sitting there watching this is more than just a tech headline. It's a profound personal challenge to what you consider possible. What happens when a machine built by human hands begins to operate on a level that defies human comprehension? To truly grasp the miracle of Willow, you need to understand the nightmare that is quantum computing. For decades, it's been the holy grail of technology, promising unimaginable power, but always just out of reach because of one devastatingly simple problem: errors. Your laptop, the phone in your pocket, they run on bits. Simple, reliable, and sturdy. A bit is either a 0 or a 1. It's a light switch that's either on or off. You can build billions of them, and they work together perfectly. Quantum computers use qubits. And a qubit is a ghost. It exists in a state of superposition, meaning it can be a 0, a 1, or somehow impossibly, both at the same time. This is where the magic comes from. It's like a single switch that can be on-off, and every shade of dimness in between all at once. This allows quantum computers to explore a vast landscape of possibilities simultaneously. But this ghostly power comes at a terrible price: fragility. Qubits are the most sensitive things in the known universe. A stray particle of cosmic radiation from a distant supernova, a tiny fluctuation in temperature, even a subtle vibration from a truck driving down the street, any of these can cause the qubit to collapse. This is called decoherence. The ghost solidifies, the magic vanishes, and your entire calculation is ruined. For years, this was the Great Wall. The more qubits you added to get more power, the more points of failure you introduced. The problem didn't just grow. It grew exponentially. Scientists believed that to get just a handful of stable, error-corrected logical qubits, you would need millions of these fragile physical qubits to act as a support system, constantly checking and correcting each other. Imagine trying to build a skyscraper out of soap bubbles during a hurricane. That's what scaling a quantum computer was supposed to be like. Google's Willow Chip has 105 qubits. By all conventional logic, managing 105 of these should be an act of pure, unadulterated chaos. The famed physicist Brian Greene, who made string theory a household idea, used a beautiful analogy. It should be like trying to balance 105 perfectly sharpened pencils on their tips, simultaneously, during an earthquake. But Willow doesn't just balance them. It makes them dance a perfectly choreographed ballet. It performs with a level of precision that physicists thought was 50 years away, if ever. It's as if someone not only built a skyscraper of soap bubbles in a hurricane, but found that the hurricane itself was helping to hold the bubbles together. This defiance of the odds has a deeply personal echo. Have you ever faced a problem in your own life, in your career, your health, your relationships that felt utterly insurmountable? A situation where every step forward seemed to invite 3 steps back, where the chaos felt destined to win. Willow is a testament to the idea that sometimes the impossible isn't impossible at all. It's just a problem we haven't looked at from the right angle yet. Let's try to wrap our minds around the power we're talking about here. because words like fast don't even begin to cover it. The benchmark test for these machines is a specific, complex calculation designed to be easy for a quantum computer, but brutally hard for a classical one. Willow completed this calculation in under 5 minutes. How long would that same task take the most powerful classical supercomputer on Earth today? A machine like Frontier or Aurora, which fills an entire building and consumes enough power to run a small town. It would take that supercomputer approximately 10 septillion years. Let's pause on that number. A septillion is a 1 followed by 24 zeros. It's a number so vast, it's functionally meaningless to the human brain. So let's try to give it some scale. The universe, from the Big Bang until right now, is about 13.8 billion years old. To get to 10 septillion years, you would need to live through the entire age of the universe not once, not twice, but nearly 1 billion times over. Willow did it in the time it takes to make a cup of coffee. This isn't just an increase in speed. It is a fundamental break from the constraints of time. It's as if Willow isn't just calculating an answer. It's reaching across eons, plucking a solution from a point in time so distant our species, our planet, and our sun will have long turned to dust, and delivering it to us in the present moment. What does that mean for you? It means a world where the long, agonizing waits that define human progress could simply evaporate. Think about the process of developing a new drug. It's a decade-long billion-dollar gamble. Why? Because we're guessing. We can't perfectly simulate how a complex molecule will interact with the intricate biology of a human cell. Willow could. A problem that takes a decade of trial and error could be solved in an afternoon. Imagine your doctor taking a DNA sample and, within hours, having a drug designed specifically for your unique genetic code to fight a disease. Imagine climate scientists modeling our entire planet's weather system with perfect accuracy to predict and even mitigate disasters. Imagine designing a battery that could power your home for a decade on a single charge. These are the kinds of problems that currently live in the realm of septillion-year complexity. Willow puts them within our grasp. So I ask you, what is the biggest, most stubborn challenge in your life or in the world that you've accepted as unsolvable? What would you do with a tool that could give you the answer in minutes? The possibilities are as thrilling as they are terrifying. The reaction from the people who live and breathe this science has been a fascinating mix of euphoria, deep confusion, and a palpable sense of existential dread. This isn't just a new discovery. It's an anomaly that threatens to upend entire fields of physics. Dr. John Preskill, the physicist who literally coined the term quantum supremacy, admitted that Willow represents a leap in quantum error correction he didn't expect to see for decades. But here is the part that is sending whispers through the halls of every university and research lab. Even the Google engineers who built Willow cannot fully explain how it works. They can run the tests. They can measure its staggering output. They can replicate the results over and over. But the underlying mechanism, the why behind its impossible stability, seems to violate our known models of quantum mechanics. It's a black box. They've built a miracle engine, but they don't have the blueprint for the miracle. This has split the community. On one side, you have thinkers like Preskill, who cautiously suggest we may be getting our first tantalizing glimpse of new physics. That there are rules to the universe, deeper and more subtle than relativity or quantum mechanics, that we have yet to discover, and Willow has accidentally stumbled upon one. On the other side, you have respected skeptics like Dr. Scott Aronson, who urge caution. He warns that it's easy to mistake exotic, complex patterns for new laws of nature. Perhaps, he argues, it's not new physics, but an incredibly complex interplay of known physics that we just don't have the mathematics to describe yet. This debate is far more than academic. It mirrors a fundamentally human experience. Have you ever had a moment in your life where something you held as an absolute truth was shattered by a new experience or a piece of information? Maybe it was a belief about yourself, about a relationship, or about the world. That disorienting, frightening, yet strangely liberating feeling of standing on shifting ground. That is what the entire scientific community is feeling right now. Willow is forcing us to question our core assumptions and embrace a profound uncertainty. It's a powerful reminder that sometimes the greatest discoveries aren't found in the answers we get, but in the moments we realize we've been asking the wrong questions. And this is where the story leaps from the pages of a scientific journal and lands squarely in the realm of mind-bending science fiction. Faced with a machine that seems to defy the laws of our reality, some physicists are daring to ask a radical question. What if it's not? What if Willow isn't breaking the rules of our universe, but is instead borrowing resources from others? This brings us to the many worlds interpretation of quantum mechanics. It's a theory that suggests that every time a quantum event has more than one possible outcome, the universe splits. Every choice, every possibility branches off into its own parallel reality. You chose to watch this video? In another universe, a version of you is doing something else. That qubit that could be a 0 or a 1. In one universe, it's a 0, and in another, it's a 1. The theory proposes that Willow's astonishing ability to self-correct isn't just clever engineering within our single reality. It might be that the chip is acting as a conduit, a bridge to these parallel universes. When a qubit in our universe is about to decohere and cause an error, it could be communicating or interacting with its counterparts in adjacent realities, effectively averaging out the errors across countless worlds. The computation isn't just happening on this one chip in our world. It's being performed by a near-infinite ensemble of Willows across the multiverse. Let that sink in. This chip would not just be a computer. It would be a multiverse engine. This idea transforms the very nature of reality from a single, lonely timeline into a vast, interconnected web of possibilities. And it makes the implications intensely personal. Think about the major crossroads in your life, the career path you chose, the person you married, the city you live in. We all live with the ghosts of our what-ifs. The many worlds theory says those what-ifs are real places, where other versions of you are living out the consequences. What would you do if you could glimpse the outcomes of your biggest decisions as lived out by your parallel selves? If you could run a simulation of your life's choices across 1,000 different realities to find the optimal path, Willow's potential suggests that such scenarios may no longer be just philosophical daydreams. It challenges you to think not just about the one life you're living, but the infinite potential paths your existence could take. While scientists wrestle with the cosmic implications, the practical applications of Willow are poised to cascade into your world with breathtaking speed. But for every miracle, there is a shadow. First, the magic of medicine. As we discussed, Willow could design hyper-personalized drugs in days, not decades. Imagine a world where diseases like Alzheimer's, Parkinson's, or many forms of cancer are not just managed, but cured by molecules tailored to your specific DNA. This is the promise, a future free from ailments that have plagued humanity for millennia. Have you or a loved one ever been told by a doctor, "We'll have to wait and see"? Willow could eliminate that wait. But here's the shadow. Who gets access to this power? Will these miracle cures be available to all, or will they create a new, terrifying biological class divide? A world where the wealthy can purchase cures for aging and disease, while the rest are left behind. The gap between the haves and have-nots could become a chasm between the mortal and the near immortal. Next, consider energy and materials. Willow could design materials from the quantum level up. Room temperature superconductors that would enable lossless power grids, saving trillions of dollars and dramatically cutting our carbon footprint. Batteries that could power a car for its entire lifespan. Think about your utility bills, the cost of gas, your personal impact on the environment. This technology could revolutionize it all, leading to a cleaner, cheaper, more abundant future. The shadow? The economic upheaval would be monumental. Entire industries, oil and gas, traditional manufacturing, logistics could be rendered obsolete almost overnight. The transition could lead to massive job displacement, creating social and political instability on a global scale. Finally, there's artificial intelligence. Willow could supercharge the development of AI, pushing us rapidly toward artificial general intelligence, AGI machines with the cognitive abilities of a human. An AGI could be the ultimate partner, an assistant that could solve humanity's most complex problems. It could revolutionize education, science, and creativity. The shadow is the one that science fiction has warned us about for a century. How do you control an intelligence that is exponentially smarter than its creator? What happens to human purpose in a world where our intellect is no longer the most powerful force on the planet? Are you comfortable with an AI that not only anticipates your needs, but understands you better than you understand yourself? And towering over all of this is the specter of security. Willow's power will be able to shatter every form of modern encryption in minutes. Your bank accounts, government secrets, corporate data, your private messages, all of it laid bare. Simultaneously, it could create new forms of quantum encryption that are truly unbreakable. The danger is a world of digital feudalism, where quantum-powered nations or corporations are invulnerable, and everyone else is transparent and defenseless. How will you navigate a career, or even just your daily life, in a world where privacy is a commodity for the powerful? This isn't some distant, far-off future. Elon Musk aptly noted, quantum computing doesn't just change what we can calculate. It changes what calculation means. The timeline has been radically compressed. What experts thought would take 30 to 50 years is now projected to happen within 5 to 10. Within a decade, we will likely see quantum computers outperforming classical computers on real-world, commercially relevant problems. This isn't like the slow dawn of the internet age. This will be a tidal wave. The quantum advantage will touch your job, your finances, your health, and the very fabric of society. So, this brings us back to you. We've journeyed from a tiny chip to the very edge of the multiverse. We've seen the promise of utopia and the peril of dystopia. Google's Willow Chip has opened a door, and we are all, ready or not, about to step through it. It's a moment that brings to mind Einstein's famous quote, "The most incomprehensible thing about the universe is that it is comprehensible." Willow challenges that. Perhaps the universe is only comprehensible up to a point, and we've just knocked on the door of what lies beyond. The lesson here is not one of technology, but of human adaptation. The single most valuable skill you can cultivate in the coming years is not coding, not engineering, but curiosity-driven adaptability. It's the willingness to unlearn what you thought was true and embrace a new reality. Just as Willow defies the chaos that should destroy it, you can thrive in the coming chaos by refusing to be rigid. So here's my advice, my takeaway from this incredible story. Don't wait to be disrupted. Start preparing now. You don't need to become a quantum physicist. Just start by making curiosity a daily habit. Read one article a week about an emerging technology in your field. Ask the question, how could this change what I do? Talk to your colleagues, your friends, your family about these changes. The quantum revolution will be built not just by scientists, but by all of us and how we choose to respond to it. As we stand on this threshold, the question isn't if the quantum future will arrive, but if we will be ready when it does. What are your thoughts on this quantum leap? Does the idea of a multiverse-powered future fill you with excitement? Or does the potential for misuse and inequality concern you more? How are you preparing, in your own life and career, for a world where the impossible becomes routine? Share your thoughts in the comments below. I genuinely want to hear how you're processing this new reality.